Baalbek stands among the most astonishing archaeological sites ever discovered in the Mediterranean. Located in Lebanon's Bekaa Valley, around 85 kilometers northeast of Beirut and more than 1,100 meters above sea level, the site has been inhabited since the Bronze Age. Long before Roman rule, it served as a sacred center for ancient civilizations, with evidence suggesting its religious importance stretched back at least 2,000 years before the Romans arrived. When the Romans took control, they renamed the city Heliopolis, meaning City of the Sun. Between roughly 60 BC and the early 3rd century AD, they transformed it into an immense religious sanctuary featuring the Temple of Jupiter, the remarkably preserved Temple of Bacchus, and the elegant circular Temple of Venus. Even today, historians regard Baalbek as the largest Roman temple complex ever built beyond the borders of Rome itself. Yet the greatest mystery is not the temples rising above the ground. It lies beneath them. The Temple of Jupiter rests on an enormous artificial platform constructed from gigantic limestone blocks. Along the platform's western retaining wall are 3 colossal stones collectively known as the Trilithon. Each measures about 19 meters long, 4 meters high, and 3.5 meters wide, with an estimated weight of nearly 800 metric tons. For more than a century, these blocks have challenged archaeologists and engineers alike, because no universally accepted explanation exists for how they were transported and positioned with ancient technology. The puzzle becomes even more remarkable when visiting the nearby quarry, located about 900 meters southwest of the temple. There, several unfinished megaliths remain exactly where they were carved. The most famous is Hajar al-Hibla, or the Stone of the Pregnant Woman, known for centuries and weighing close to 1,000 metric tons. Later investigations uncovered an even larger stone of roughly 200 metric tons, but the biggest surprise came in 2014 when archaeologists from the German Archaeological Institute and the Lebanese University revealed another unfinished block weighing an astonishing 1,650 metric tons, the largest known worked stone ever identified from the ancient world. Unlike the Trilithon blocks, this enormous stone never left the quarry. Its unfinished state offers a rare glimpse into the ambitions of the builders, showing that they intended to extract stones even larger than those already incorporated into the temple foundation. The discovery raises a fundamental engineering question. If the builders planned to move a block of this size, what techniques were they expecting to use? Roman engineering achievements are legendary. They constructed aqueducts, bridges, roads, amphitheaters, and military fortifications that have survived for nearly 2 millennia. Ancient authors such as Vitruvius documented Roman construction methods in considerable detail. However, those surviving records provide no clear evidence that Roman engineers possessed the lifting systems, transportation methods, or construction equipment necessary to handle limestone blocks weighing 800, 1,000, or even 1,650 metric tons. This discrepancy has fueled one of archaeology's most enduring debates. The quarry is unquestionably real, the unfinished stones still exist, and the Trilithon remains embedded within the Temple of Jupiter's foundation. Together, they present a challenge that has never been fully resolved. Who originally designed this massive platform? What technology allowed such enormous stones to be quarried and positioned with remarkable precision? And whether the Romans inherited an earlier foundation or built it themselves? To appreciate why Baalbek continues to fascinate engineers and historians alike, it is essential to compare the documented capabilities of Roman construction with the physical evidence preserved at the site. Only by examining both can we understand why the Baalbek megaliths remain one of the greatest engineering mysteries of the ancient world. Roman engineering was extraordinary. The Romans built structures that have survived for 2 millennia. The Pantheon in Rome, completed around 126 AD, features a concrete dome that remained the largest in the world for over 2,300 years. Roman aqueducts carried water across valleys and mountains with a precision of gradient that modern engineers find impressive. Roman roads, bridges, and harbors demonstrated a mastery of large-scale construction that was not matched in Europe for over 1,000 years after the empire's fall. The Romans documented their engineering methods. Vitruvius, writing in the 1st century BC, produced De Architectura, the most comprehensive surviving Roman treatise on engineering and construction. The work describes cranes, pulleys, treadwheel systems, and the methods Romans used to quarry, transport, and lift heavy stones. Frontinus, writing in the late 1st century AD, documented Roman aqueduct construction in De Aqueductu, providing additional insight into the scale and methods of Roman civil engineering. These texts describe what the Romans could do. They describe crane systems capable of lifting stones of 6 to 9 tons routinely. They describe coordinated systems, multiple cranes working together, combined with inclined planes and rollers that could move larger blocks. The largest documented Roman lifting operations involve stones of perhaps 30 to 50 tons. The stone of Theodoric, a roughly 300-ton block that the Romans moved to Ravenna for the mausoleum of Theodoric the Great, represents the upper limit of what Roman engineering is documented to have accomplished with stone transport. 300 tons is impressive. 300 tons is not 800 tons. 300 tons is not 1,000 tons. 300 tons is not 1,650 tons. The gap between documented Roman capability and the Baalbek stones is not a minor discrepancy. It is a factor of 3 to 5 times beyond anything the Romans are known to have moved anywhere else in their empire. The engineering problem is specific. Moving a stone weighing 800 tons requires more than scaling up the methods used for smaller stones. The mechanical stresses increase geometrically. The friction forces that must be overcome are enormous. The ground itself becomes a limiting factor. A stone weighing 800 tons exerts pressures that would destroy any road surface the Romans are known to have built. The quarry at Baalbek is 900 millimeters from the temple platform. The terrain between them is not flat. The stones would have had to be transported over uneven ground, positioned precisely, and lifted into place on top of existing foundation layers. The lifting alone would have required mechanical systems far beyond anything described in the Roman engineering literature. The Trilithon stones are not at ground level. They are elevated, placed on top of lower courses of foundation stones, themselves substantial blocks weighing hundreds of tons. Someone had to lift blocks weighing 800 tons to height. Someone had to position them with the precision visible in the finished construction. Tight joints, aligned faces, the craftsmanship of monumental architecture. The standard archaeological explanation attributes the construction to Roman engineers working during the imperial period. The explanation is not satisfying. It does not explain how. It simply asserts that the Romans must have done it because the temple complex is Roman. The temple complex is demonstrably Roman. The columns are Roman. The carved decorations are Roman. The architectural style is Roman. The historical records place Roman construction at Baalbek during the reigns of Augustus, Nero, Trajan, and subsequent emperors. But the foundation platform, the massive podium on which the Roman temple sits, may not be Roman at all. The German Archaeological Institute has been conducting systematic research at Baalbek since the late 19th century. Otto Puchstein led the foundational German expedition between 1898 and 1905. Working with Theodor Wiegand, Puchstein produced detailed documentation of the site that remains valuable to researchers today. Subsequent generations of German archaeologists have continued the work. Margaret van Es has directed the German Archaeological Institute's Baalbek research in recent decades. Klaus Stefan Freiberger has published extensively on the site's architectural history. Daniel Lohmann, the architect-archaeologist who co-led the 2014 discovery of the largest quarry stone, has contributed detailed analysis of the construction phases. The German research has established important facts. The temple complex was built in phases over approximately 2 centuries. The Temple of Jupiter was begun under Augustus and continued under subsequent emperors. The Temple of Bacchus was constructed during the Antonine period in the mid-2nd century AD. The Temple of Venus was added in the 3rd century. But the research has also revealed something the popular summaries often omit. The foundation platform predates the Roman temple construction. The Romans built their temple on top of an existing structure. The Trilithon stones, the 800-ton blocks that form the western retaining wall, are not demonstrably Roman. They may be Roman. The mainstream archaeological position assigns them to the Roman construction period. But the evidence for this attribution is circumstantial rather than definitive. No Roman inscription marks the Trilithon. No Roman engineering document describes how the stones were moved. No comparable stones exist anywhere else in the Roman world. The attribution rests on the assumption that, because the temple is Roman, the foundation must also be Roman. The assumption may be wrong. Baalbek was a major religious site long before the Romans arrived. The Phoenicians occupied the Baalbek Valley from at least 2000 BC. They established a cult center at Baalbek, dedicated to their god Baal, the lord of the sky, the god of storms and fertility, whose name survives in the site's name. Baalbek means Lord of the Bka. The religious continuity at the site spans millennia. The Romans did not create a new sacred site at Baalbek. They appropriated an existing one. They identified the local god with their own Jupiter, a standard Roman practice throughout the empire, syncretizing local deities with the Roman pantheon to ease the incorporation of conquered peoples. The Temple of Jupiter at Baalbek was not a new religious foundation. It was the Roman phase of a worship tradition that extended back at least 2,000 years before Roman construction began. The question that the foundation platform raises is whether the Romans built it or whether they built upon it. Macrobius, writing in the 5th century AD, recorded traditions about Baalbek in his Saturnalia that emphasized the site's antiquity. He described the worship practices and noted the religious significance that predated Roman occupation. Local Lebanese and Islamic traditions have long associated Baalbek's foundation with figures from deep antiquity. Some traditions attribute the platform to Solomon. Some traditions attribute it to the jinn, supernatural beings in Islamic cosmology who possess powers beyond ordinary humans. These traditions are folklore, not history, but they preserve a memory, a recognition that the foundation of Baalbek predates the Roman temple, that someone else built the massive platform that the Romans later appropriated. The quarry stones confirm that whoever began the foundation work intended to continue on an even larger scale. The stone of the pregnant woman, Hajar al-Hibla, has been visible for centuries. It lies partially extracted from the bedrock, abandoned at an angle, never transported to its intended destination. At approximately 1,000 tons, it is larger than any of the Trilithon stones that were successfully moved and placed. The 1990 discovery added another stone to the quarry inventory, approximately 1,200 tons, also abandoned, also never moved. The 2014 discovery changed the scale of the question entirely. Daniel Lohman and Janine Abdul Masi, excavating beneath the stone of the pregnant woman, found an even larger block. The stone measures approximately 6 meters in length, 6 meters in width, and 5.5 meters in height. Its estimated weight is approximately 1,650 metric tons. It is the largest worked stone ever documented in the archaeological record of any human civilization. It is larger than any Egyptian obelisk. It is larger than the unfinished obelisk at Aswan, itself a remarkable engineering achievement at approximately 1,168 tons. It is larger than anything the Romans moved anywhere else in their empire by a factor of more than 5. And it was being prepared for transport. The quarrying work on the stone was deliberate. It was being extracted for a purpose. The purpose, presumably, was to join the Trilithon to become part of the foundation platform that already included 800-ton blocks. The work was abandoned. The stone was never moved. But the intention was clear. Whoever was building the foundation at Baalbek was planning to move stones of 1,000 tons, 1,200 tons, 1,650 tons. They had already moved stones of 800 tons. The Trilithon proves that the transport of 800-ton stones was achieved, not planned, not attempted, but accomplished. The quarry stone suggests that the builders considered 800 tons a baseline, not a limit. They were planning to go bigger. The engineering implications are staggering. Modern heavy lift equipment can move loads of this magnitude. The crawler transporter that NASA uses to move the Space Launch System weighs approximately 2,700 tons and can carry loads of up to 8,000 tons. It is a modern engineering marvel built with 20th century and 21st century technology, powered by diesel engines and running on specially designed roadways. Moving an 800-ton stone block in antiquity without diesel engines, without steel cables, without hydraulic systems, would require methods that no ancient engineering text describes. Some researchers have proposed hypothetical methods: wooden rollers, lubricated trackways, massive coordinated labor forces, lever systems, earthen ramps. Each proposal encounters specific problems. Wooden rollers of the size needed to support 800 tons would themselves be enormous and would crush under the point loading that such a weight would produce. Lubricated trackways might reduce friction, but the ground pressure would still exceed what any ancient road surface could sustain. Labor forces large enough to pull 800 tons would require coordination systems, communication, timing, and load distribution, systems that are difficult to achieve with human muscle power at this scale. Lever systems face fundamental mechanical limits. The lever arms required to lift 800 tons would be so long that the levers themselves would fail under their own weight. Earthen ramps could reduce the lifting problem to a pulling problem, but the ramp required to raise an 800-ton stone to the height of the Trilithon would be an engineering project in itself, requiring millions of cubic meters of fill material. None of the proposed methods have been demonstrated. None have been tested at scale. None appear in the Roman engineering literature. The standard archaeological position is that the Romans must have done it because no one else could have. The logic is circular. The Romans are assumed to have built the foundation because the foundation exists, and because the Romans built the temple. But the foundation might predate the temple. The foundation might be the work of an earlier civilization, Phoenician or older, whose engineering methods are not preserved in any surviving text. The foundation might represent capability that we do not understand because the builders left no written record. The honest assessment is that we do not know how the Trilithon stones were moved. We do not know when they were moved. We do not know who moved them. We know they exist. We know they weigh approximately 800 tons each. We know they were transported from a quarry 900 meters away and lifted into position with precision. We know whoever did this was planning to move even larger stones, stones that were quarried and prepared but never transported. The mystery is not whether the stones are real. The mystery is how. The site was designated a UNESCO World Heritage Site in 1984. The Directorate General of Antiquities, Lebanon, oversees its preservation and management. Research continues. The German Archaeological Institute and Lebanese University maintain ongoing excavation and documentation programs. New technologies, ground-penetrating radar, photogrammetric mapping, and structural analysis are being applied to the site. But the fundamental question remains unanswered. The methods are unknown. The timeline is uncertain. The builders are unidentified with certainty. The comparison to Egypt is instructive. The unfinished obelisk at Aswan, at approximately 1,168 tons, is often cited as the closest parallel to the Baalbek quarry stones. But the Aswan obelisk was never moved. It cracked during quarrying and was abandoned. We do not know whether the Egyptians could have moved it if they had successfully extracted it. The Baalbek Trilithon stones were moved. They are not in the quarry. They are in the temple foundation, 900 meters away, lifted into position, fitted with precision. Whatever the method was, it worked. It worked repeatedly, 3 times for the Trilithon, and for the numerous other multi-hundred-ton blocks in the lower foundation courses. The builders were not experimenting. They had a system. They were executing a plan. And then they stopped. The quarry stones, the stone of the pregnant woman, the 1,200-ton block, the 1,650-ton megablock, were abandoned. The work ceased. The Romans arrived and built their temple on top of what already existed. The transition raises its own questions. Why was the work abandoned? What happened to the builders? Why did the Romans, who were capable engineers, not continue the foundation work on the same scale? The Roman additions to the site are impressive, but they are built with smaller stones. The columns of the Temple of Jupiter, while enormous, are assembled from drums rather than monolithic blocks. The temples rising above Baalbek clearly reflect Roman architecture, but the enormous foundation beneath them tells a far more complicated story. While the structures above match what historians expect from Roman engineering, the massive platform supporting them appears to belong to an entirely different scale of construction. Whether that difference represents a lost building tradition, an earlier civilization, or simply an engineering achievement we have yet to understand remains one of archaeology's most debated questions. For centuries, local legends have tried to fill that gap. Some traditions credit the foundations to King Solomon, while others speak of giants or supernatural beings. These stories cannot be treated as historical evidence, yet they reveal something important. Even ancient observers believed the foundation stones were so extraordinary that ordinary explanations seemed insufficient. Modern archaeology approaches the site from a different perspective. Most scholars attribute the visible temple complex to Roman builders and remain cautious about theories involving forgotten civilizations or advanced prehistoric technology. That caution is justified, as sensational claims have often overshadowed genuine archaeological research and have sometimes diminished the accomplishments of ancient societies. Still, rejecting unsupported theories does not eliminate the engineering questions posed by Baalbek itself. Those questions remain very much alive. The enormous stones exist, their dimensions are measurable, and their placement is undeniable. The challenge lies in explaining exactly how they were quarried, transported, and fitted with such precision. While several researchers argue that Roman engineers possessed the organization, manpower, and determination needed to complete the task, no universally accepted reconstruction has demonstrated the complete process from quarry to foundation. Among the leading researchers, Daniel Lohmann has suggested that Roman engineering could account for the Trilithon if sufficient labor and planning were employed. His interpretation is certainly possible, but possibility alone is not proof. Until the entire sequence can be convincingly recreated, the practical mechanics behind moving blocks weighing hundreds of tons remain open to debate. Dating the foundations presents another obstacle. Limestone cannot be directly radiocarbon dated, and quarry marks reveal little about when the stones were cut. As a result, archaeologists must rely on surrounding archaeological layers and the relationship between the foundations and the unquestionably Roman temple above them. Unfortunately, that evidence has not produced a definitive answer. Because of this uncertainty, several possibilities remain under consideration. The foundations may have been constructed during the Roman period. They may belong to an earlier culture that the Romans later incorporated into their grand sanctuary. Or they could represent a much older phase of construction whose origins have yet to be identified. At present, none of these explanations has been proven beyond doubt. After more than a century of systematic excavation and study, Baalbek continues to resist a complete explanation. The temples themselves fit comfortably within Roman architectural history, but the platform beneath them raises questions that extend beyond the limits of surviving Roman engineering records. The nearby quarry strengthens that mystery even further. The unfinished megaliths reveal that the builders were not satisfied with 800-ton blocks. They intended to extract stones exceeding 1,600 metric tons, larger than any other known worked stones from antiquity. The largest unfinished block demonstrates remarkable ambition. Whoever planned the project was not experimenting with an impossible dream. They were following a construction strategy that must have made sense within the technology available to them. Unfortunately, the methods they relied upon have not survived. The stones remain, but the knowledge behind them appears to have vanished. That is why Baalbek continues to captivate historians, engineers, and archaeologists alike. The mystery is not born from a lack of evidence. On the contrary, the evidence is overwhelming. Massive stones still rest within the foundation, even larger ones remain abandoned in the quarry, and their sheer size challenges every conventional explanation. We know they were carved, we know some were transported, we know they were placed with astonishing precision. What we still do not know is exactly who accomplished the feat, when it was done, or by what methods. For more than 2,000 years, the silent stones of the Bekaa Valley have guarded those answers. The Roman temples stand proudly above them, But the foundations continue to pose the same unanswered question. Were they built by the Romans using techniques now lost to history, or do they preserve the legacy of an even earlier civilization whose engineering knowledge disappeared long ago? Until stronger evidence emerges, Baalbek remains one of the greatest unsolved engineering mysteries of the ancient world.